Gravitational waves. Gravitational waves. What are they? How do they happen? Why should you care? I mean, you don't have to care, right? But it's pretty interesting. So, what are gravitational waves? Okay, we're going to take this from the top. First, starting with the way gravity works as predicted by Albert Einstein. So basically, Einstein believed that the universe was arranged on this fabric made up of space and time. Imagine a blanket stretched real tight, almost like a canvas. This is the fabric of the universe. Now imagine that a bowling ball is placed on the blanket. The bowling ball would cause a curve in the blanket, stretching the fabric around it. Now imagine that there are various bowling balls spread out across the blanket, representing planets, stars, and other objects of large mass, and other smaller balls, representing things of smaller masses. And they're all in the blanket. The smaller balls end up rolling towards the larger balls due to the curves that the larger ones form and roll around them in orbit. This is a pretty simplified representation of the way objects of different masses interact with each other due to the fabric of space and time. Okay, now that we've got that down, let's get to the gravitational waves. Gravitational waves, simply speaking, are ripples in the fabric of space and time. They're caused by very violent and energetic processes that occur in the universe. Einstein's mathematics showed that accelerating objects of huge masses, such as black holes or neutron stars orbiting each other, would disturb spacetime, causing waves of distorted space to spread from the origin. These ripples would travel at the speed of light, cluing us in about their violent source, which can then help us better understand the way gravity works. Proof of gravitational waves. Einstein predicted the existence of gravitational waves way back in 1916, but we didn't have any actual proof of them occurring. That is, until 1974, when two astronomers working at the Arecibo Radio Observatory discovered a binary pulsar, two extremely heavy stars orbiting each other, which is exactly the type of system that should produce gravitational waves, according to general relativity. Astronomers measured how the period of the stars' orbits changed over 8 years, and determined that the stars were getting closer to each other exactly as predicted by general relativity, erasing any doubt that it wasn't producing gravitational waves. On February 11th of this year, LIGO released that they had first detected gravitational waves on December 14, 2015 at 5:51 a.m. by the Twin Laser Interferometer Gravitational Wave Observatory (LIGO) detectors. This was the first observation of gravitational waves affecting Earth as they passed through. The press release states, "At each observatory, the 2.5-mile-long L-shaped LIGO interferometer uses laser light split into two beams that travel back and forth down the arms, 4-foot diameter tubes kept under a near-perfect vacuum. The beams are used to monitor the distance between mirrors precisely positioned at the ends of the arms. According to Einstein's theory, the distance between the mirrors will change by an infinitesimal amount when a gravitational wave passes by the detector. A change in the lengths of the arms smaller than 1/10,000th the diameter of a proton can be detected." Scientists believe the waves were caused by the collision of two black holes about 1.3 billion years ago. It's pretty cool. So what does this mean for science and people in space? Why does it even matter? Well, gravitational waves that people will be able to detect will be caused by superhuge occurrences in the universe. The information carried by gravitational waves will become essential knowledge after analyzation. People will be able to observe the universe in a way never seen before, allowing us to gain a better understanding of the phenomenon that takes place in space and opening new areas of study in the fields of physics, astronomy, and astrophysics.